In this video, we're going to talk about different types of logic and more the breakdown of logic. We're also going to talk about counterexamples again. So first off, we're going to talk about conditional statements. I did briefly mention this in the previous video, but a conditional statement is a logical statement that has two parts, and it is a hypothesis and a conclusion. When a conditional statement is written in if-then form, the if part contains the hypothesis, and the then part contains the conclusion. So for example, if I say, if it is raining, then there are clouds in the sky. So the P part of the sentence is the hypothesis, and the Q part is the conclusion. So a counterexample is any example that proves the conditional is false. There are many ways of showing a counterexample. One can be a picture, you could use an equation, or you could just write a sentence describing what's different. Or a sentence just describing and how it is wrong. So sorry, I had to type those instead of writing it. My tablet was going a little crazy. We talked about counterexamples before, so here we're going to decide whether the statement is true or false, and if it's false, we need to provide a counterexample. So if a polygon has 5 sides, then it is a regular polygon. So they're trying to tell us that it's always going to be a regular polygon, but we know that doesn't always have to be the case. It doesn't have to be regular, so it doesn't have to have all the sides and angles congruent inside. So what we could do is show a picture of a non-regular polygon that has 5 sides. For number 2, it says if the measure of angle A is 85 degrees and the measure of the complement is 5 degrees. Well, you have to remember the complement is 90 degrees together. So if we have 85 degrees and we have 5 degrees, they do add up to be 90 degrees. So this would be a true statement. So next, supplementary angles are always a linear pair. So this would be false, and that's because we have to know the difference between supplementary and linear pair. Supplementary just means that they add up to be 180 degrees. Linear pair means they need to also be adjacent and add up to be 180 degrees. So we could have supplementary angles that are not adjacent. Alright, for these different types of conditional statements, put a big star next to these. You need to know the difference between the converse, inverse, and contrapositive, and those are the ones that you're most likely going to get mixed up. So first, the converse, we are to write the converse of a conditional. We need to exchange the hypothesis with the conclusion. So we're switching, or you can call it kind of flipping, the order of your sentence. For the inverse, we need to negate both the hypothesis and the conclusion. And what negation means, it means you're doing the opposite of the statement. So if there is any words that you need to remove the word not before each part, or does not, or do not, or you need to insert it if it doesn't already have it there to mean that it is the opposite of that part. So if it says, if it is raining, then you would say, if it is not raining. So next, the last one is contrapositive. The contrapositive is the converse and the inverse of a conditional. So we have to negate it and flip it. So first off, before we write the conditional, the converse, inverse, and contrapositive of the statement given, since basketball players are athletes, I'm going to first give you the symbols that will help you tell you what order you need to write these in. So P to Q, that means that it is your normal hypothesis, your normal conclusion, so your regular conditional statement. Then next, for converse is flipping it. So remember flip, so we're going to be putting Q first and then the P second. So we're switching the order of our sentence. Inverse then means that we are keeping it as P and Q, except we're doing the not of P and the not of Q. So we showed this by putting a little tilde symbol, P, and then our arrow to the tilde of Q. So it's showing that it's not. Or the negation of P and the negation of Q. So contrapositive is doing both. So flipping them and doing the nots. So not only do we need to flip it, but we need to put the negation part in there. So for our statements up here, for the conditional statement, if we have basketball players are athletes, we just need to make it so it's an if-then statement. So if you play basketball, then you are an athlete. So we're going to go through and write all the statements first, then we're going to go back and see if the statements are true or false. So for the next one, for the converse, since we need to, let's go ahead and label each of the parts of our sentence also. So if we play basketball, that part is our P, or the hypothesis. You are an athlete is the conclusion, so that's the Q. So for the converse, we need to put the athlete part first and then the basketball part second. So if you are an athlete, then you play basketball. For the inverse, we need to go back to the original order, and we need to put the negation of each of those in there. So if you do not play basketball, then you are not an athlete. For the last one, for the contrapositive, basically you're taking the converse and putting the negation with it. So we're keeping it switched. So if you are an athlete, then you play basketball, but now we're doing the opposite of that. So if you are not an athlete, then you do not play basketball. All right, so now we're going to do the true or false statements of them to figure out if those statements we just wrote are true or false. So if you play basketball, then you are an athlete. So what you want to think of is the conclusion always going to be that conclusion? So if you play basketball, are you always an athlete? So most cases are yes, that you should be an athlete then if you're playing basketball. So if you are an athlete, then you will always play basketball. And that is not always true, because we could be playing some other sport. If you do not play basketball, then you are not an athlete. So if you do not play basketball, then you are not always an athlete. And this could be false, because you could be a runner, you could play soccer, you could play some other sport instead. So for the last one, contrapositive, if you are not an athlete, then you do not play basketball, and this would be true. All right, so for this example, it's the same idea. So all 180-degree angles are straight angles. So for the conditional statement, we just need to change it to an if-then statement. If it is a 180-degree angle, then it is a straight angle. And this would be a true statement. So for the next one, for the converse, we need to switch the order, or this is where we flip it. So if it is a straight angle, then it is 180-degree angle. This would also be true. Oh, there we go. Because when it's a straight angle, then it means it's automatically 180 degrees. For the inverse, we need to start with the conditional statements, the one up here at the top, and then we need to put the negation with it. So if it is not a 180-degree angle, then it is not a straight angle. For the contrapositive then, we need to switch the order, and we need to put the negation in there. So if it is not a straight angle, then it is not a 180-degree angle. And both of these last statements are also true. Sorry about that beeping, that was an announcement. But the last two statements, your inverse and contrapositive, are both true statements as well. So for number 4, which statement or statements, I want to add in there, so you could have more than one, has a false converse. You have to remember that converse is flipping the order. So for this very first one, if two angles are supplementary, then the sum of their measures is 180. So the converse would be, if the sum of their measures is 180 degrees, then the two angles are supplementary, and that would not necessarily be true, so that would be a false statement. Okay, take that back, that is a true statement. So if we have 180 degrees, then we know that they are supplementary. So we know A cannot be the answer. So for the next one, for B, if it is a quadrilateral with 4 right angles, then the figure is a rectangle. That is not always going to be the case, so that will be one of our false statements. For letter C, if the angles are congruent, then the two angles have the same measure, and that is always going to be true. And then for letter D, if it has 4 congruent sides, then the figure is a square, and that's not always going to be the case because it could be a rhombus instead of a square. So those are the two, B and D are two that have the converse that are false. Equivalent statements are just as they sound, so when they're the same, when two statements are both true or both false. Then they are called equivalent statements. So for this next one, if this is the conditional statement of if two angles are vertical angles, then they are congruent, which of the following statements is equivalent to the original statement? So first, we need to identify if this statement to begin with is true or false to know what type of answer we are looking for. So the statement that we are given, if two angles are vertical angles and they are congruent, we know that that will always be true. So we need to find a true statement. So for each one, we have to discuss them as we go. So if two angles are congruent, then they are vertical angles. So they're saying if you start with any two angles that are congruent, then they're always going to be vertical angles, and that's not always going to be the case. So that one is not true. So going on to letter B, if two angles are not vertical angles, so try to think of a picture, two angles that are not vertical angles, then the angles are not going to be congruent. And that might not always be true because they could still be congruent, they're just not vertical angles. So you could have two angles that are just next to each other that are both 90 degrees. And they're not vertical angles, but they are congruent. So that's not always going to be the case either for letter B. For letter C, if two angles are not congruent, then they are not vertical angles. And that would be the one that does work. So that is a true statement. And because the only way for them to be vertical angles is if they are congruent. So let's check letter D and make sure that letter C is really truly our only answer. So if two angles are congruent, then they are not vertical angles. Well, if they're congruent, they could be vertical angles, but they don't necessarily have to be. But this is saying that they're definitely not going to be vertical angles. So that is going to be false. So the only one we've got down here for our answer then is our letter C is the equivalent statement. A biconditional is when a conditional statement and its converse are both true. You can write them as a single biconditional statement. To write a biconditional statement, you have to remove the if and then insert the words if and only if in between the hypothesis and conclusion. So in place of the then, really you're going to be putting the if and only if, and you're not going to have an if at the very beginning of your sentence anymore. So for number 6, if possible, write each conditional as a biconditional. So we need to make sure that the conditional and the converse are both true. If they're not true, then we cannot write a biconditional statement. All right, so for the conditional, we can check just the way it is right now. So if two angles are complementary angles, think if they add up to be 90 degrees, then the sum of their measures is 90 degrees. Well, that will always be true. For the converse, remember this is where we flip it. So if the sum of their measures is 90 degrees, then the two angles are complementary angles. And yes, that is going to be true as well. So that means for number 6 that we can write a biconditional statement. So this is what it would look like. Two angles are complementary angles if and only if the sum of their measures is 90 degrees. So if you remember, we are removing the if at the beginning, we're removing the then, and then in place of the then part in the center, we're putting that if and only if. That's how you write the sentence. For number 7, if a polygon is equilateral, then all of the sides are congruent. Well, that is a true statement, so our conditional statement will be true. Remember, for the converse, we flip it. So if all of the sides are congruent, then the polygon is an equilateral, and that is also true. So once again, we can write a biconditional statement. So remember, we remove the if, remove the then, and then in place of it, in the middle, is where we put if and only if. So a polygon is equilateral if and only if all of the sides are congruent. So for the last one, if an angle is obtuse, then it is not a right angle. So this statement alone, the conditional statement, is true. So for the converse, statement would be, if it is not a right angle, then an angle is obtuse. Well, it may not always be obtuse. It could be an acute angle. So this means that we cannot write a biconditional statement because both versions, so conditional and converse, are not true.